When we do enter the atmosphere, we're going to be going at about 12,300 miles per hour. And in just 6.5 minutes, we're going to get down to 5 miles per hour just before we land. And I'm going to explain to you exactly how we do that. It's a very interesting concept. So we start out with our cruise stage, which has been giving us our power and our communications since we launched. As soon as we get to the atmosphere, we get rid of that cruise stage. So this is what it looks like. So our cruise stage is there at the back end. We let that go. We have the aeroshell, which contains our lander in it. It hits the atmosphere, starts heating up. You can see it gets very, very hot. That's slowing it down most of the speed. So it gets to about 850 miles per hour when we pop this parachute. The parachute takes us down close to the ground. We get rid of our heat shield that's been protecting us in the atmosphere. And then we start acquiring the ground with our radar from the lander. That tells us what our elevation is and lets us know when it's time to let go. We free fall, which is absolutely terrifying for me as a project manager to know my spacecraft's falling to the ground. But we do start firing rockets, and we slow down to about 5 miles per hour by the time we actually get down to the surface. Right when we get there, we'll go ahead and turn off those retro rockets, let the dust settle literally. You can see it's kicking up a fair amount of dust. And then we have one more important step, which is to unfurl our solar arrays. Since we're the very first lander on Mars to last for an entire Martian year, so 26 Earth months, not moving and just using solar power, it's important for us to get those solar arrays out. And so that completes what we call our entry, descent, and landing phase, and now we're ready to start doing the science. One of the other things that's really interesting about this mission is it's not just one spacecraft going to Mars. It's not just InSight. We actually have two tag-alongs that flew with us on the Atlas V and have been tracking us ever since, called MARCO. So that stands for Mars Cube 1. So we have two of them, MARCO A and MARCO B. They're about the size of a briefcase, so they're not very big spacecraft at all, but their main purpose is to do a technology demonstration showing that we can put CubeSats into interstellar space. They've been successful in doing that. But we're really, really hoping that one of the other things they're going to be able to do is give us communications while we're doing our entry, descent, and landing phase. Oftentimes we've had other assets that have been able to do real-time information for that phase, but this time we don't have those assets in the right position. So we brought along our own relay assets, and they kind of look like this. There's two of them. This is the UHF antenna at the bottom. They have an X-band that'll be talking back to Earth for us. They'll fly in formation, trailing behind us, waiting for us to start giving them a UHF signal through here, and then they'll be broadcasting that back to Earth so we know what's exactly happening each step of the entry, descent, and landing process. All those steps that I showed you a little bit earlier in the video. So this is what it looks like when we get there. So the two MARCOs are on either side of InSight as it's entering. We have MRO, or Mars Reconnaissance Orbiter, that will also be collecting the data, but it can't send back the data real time. Only the MARCOs can do that real time. So we're really hoping that they work out as a technology demonstration. The MRO will be collecting that data, and about 3 hours after we land, we'll be sending that back to the Earth, just in case the MARCOs don't work. We'll still get all the information about the entry, descent, and landing.